In the world of AI, we tend to measure progress in these massive leaps. But what NVIDIA just put on the table, well, it's not just a leap. It's a fundamental shift in how artificial intelligence is going to be built and run for years. We're talking about the Rubin platform. And believe me, it's so much more than a new chip. It's basically a blueprint for a whole new kind of AI factory. For what feels like forever, this has been the mantra, right? The core belief of the entire AI industry. More compute power, you get smarter, more capable models. It's a simple, powerful idea, and it has absolutely fueled this incredible technological arms race we're all watching. Here's the thing, though. The industry has slammed into a new kind of wall. It's not just about building bigger AI models anymore. The real and, frankly, ridiculously expensive challenge is running them. Every single time you ask an AI a question, it's doing something called inference. And that constant thinking, that's the new bottleneck. And it's the exact problem Rubin was engineered to completely shatter. Okay, so here's how we're going to break it all down in this explainer. First, we'll dig into this new memory wall that's holding AI back. Then we'll look at NVIDIA's pretty radical 6-chip answer. We'll pop the hood on the hardware itself, see the kind of insane performance leap it delivers, and finally, we'll explore what this all means for the future of AI. So first things first, we really need to get our heads around this fundamental shift that's happening. The nature of the problem has changed, and it's all about this move from training to inference. Think of it like this. Training is like the years-long, billion-dollar process of sending an AI to university to learn everything it knows. It's a massive, one-time effort. But inference? That's what happens after graduation. It's the AI actually thinking, doing its job, responding to you 24/7. This relentless, memory-hungry work is where the operational costs just go through the roof, and it's pushing today's hardware to its absolute limit. And this pressure is getting way more intense because of what's next, agentic AI. We're not talking about simple chatbots here. These are autonomous systems that can handle complex, multi-step projects, like, say, planning your entire family vacation, from flights to hotels to activities, all based on your vague preferences. To do that, they need a gigantic working memory, or context memory, to keep track of everything at once. And that puts an unbelievable strain on current hardware. So the big question is, how does NVIDIA plan to smash through this memory wall? Well, the answer isn't just a faster GPU. Nope. It's a completely new philosophy they're calling extreme co-design. This right here, this is the absolute core idea. Instead of just making each little component faster on its own, NVIDIA designed everything, the GPU, the CPU, the networking, all of it, to work together as one single giant cohesive supercomputer. The rack is the computer now. And this supercomputer in a rack is built from this dream team of 6 new, deeply interconnected chips. You've got the monster Rubin GPU doing the heavy lifting, the super smart Vera CPU basically acting as the brain and directing traffic, and then a whole suite of networking chips whose only job is to move data at absolutely blinding speeds to make sure there are 0 bottlenecks. All right, let's get into the good stuff. Let's pop the hood and see what kind of generational leap we're actually talking about with this new silicon. Looking at the numbers, one thing just screams at you. Memory bandwidth. It's nearly tripled. That's the speed at which the chip can access its own memory. And when you combine that with a massive 2.5 times increase in its raw thinking power, that's the petaflops number, you get a chip that's purpose-built to feed the hungriest AIs without even breaking a sweat. And the new Vera CPU? Don't think of it like a normal processor. It's better to think of it as a dedicated data engine. Its sole purpose in life is to shovel huge amounts of data so fast that those powerful Rubin GPUs are always fed, never waiting around. It's why that connection speed between them has literally doubled. And this stat right here, this just perfectly illustrates the power of that rack scale design. The fabric that connects all 72 GPUs in a single rack has more total bandwidth than the entire internet. Just let that sink in. That's what lets the whole rack act as one giant accelerator, which is absolutely essential for these massive AI models. So specs are cool and all, but what does this actually mean in the real world? What does it do for performance and, maybe more importantly, for the bottom line? This. This is the number that completely changes the game. A 10 times reduction in cost. This means incredibly complex AI tasks that used to be way too expensive for most companies, like having an AI analyze every single customer service call in real time, suddenly become totally affordable. It takes AI from a luxury good to a mainstream utility. And hey, this crazy efficiency isn't just for running AI, it's for building it too. With Rubin, you can now train the next generation of these truly gigantic AI models using just a quarter of the hardware you would have needed before. This chart really puts it into perspective, doesn't it? And that kind of efficiency doesn't just save a ton of money, it dramatically accelerates the pace of AI research and development, making these huge frontier models so much more practical to actually build and improve. Okay, let's zoom out. How does a platform like this actually reshape the competitive landscape and the future of the entire AI industry? Well, the race is definitely heating up. While NVIDIA is doubling down on its signature all-in-one integrated approach with Rubin, its competitors, like AMD, are playing a different game. They're betting that by using open standards, they can win over developers who are wary of being locked into NVIDIA's ecosystem, hoping to create a more open and competitive market. But NVIDIA's greatest advantage might just be its ecosystem. I mean, look at this list. Virtually every major cloud provider, every top AI lab, and every big computer maker has already lined up to deploy Rubin. This massive early adoption creates this powerful network effect that's just incredibly difficult for any competitor to overcome. And NVIDIA is not taking its foot off the gas, not even for a second. They've shifted to this relentless one-year cadence. We get Rubin in 2026, Rubin Ultra in 2027, and the next big thing, Feynman, is already on the calendar for 2028. This crazy fast roadmap is clearly designed to keep them multiple steps ahead of everybody else. So, with Rubin, NVIDIA has fundamentally redefined the basic unit of computing. It's not the chip anymore, it's the entire data center rack. This move solves today's biggest problem and paves the way for that next wave of agentic AI. But the question it leaves us with is, does this giant leap cement NVIDIA's lead for good? Or does it just pour gasoline on the fire and spark an even more intense race to the top? One thing is for sure, the rules of the game have just been completely rewritten.